Hey guys, in today's video we are exploring a spatial sorting algorithm in game engine. So it is essential for optimizing game performance. The spatial sorting algorithm's job is to manage which object should appear on your screen, and it enhances the gameplay by essentially ensuring that only necessary elements are processed. So all these together creating a visually stunning game world. Whether you are a developer or a curious gamer, join us to uncover how these algorithms work and why they are vital for seamless gaming experiences. Let's get started. Spatial sorting algorithms play a vital role in optimizing rendering and collision detection in game development as well as computer graphics. How it does? It does by minimizing the number of computation required. In a game scene, there will be lots of objects to be processed, and the order of processing them will be determined by spatial sorting algorithm. The choice of spatial sorting algorithm depends on specific requirements of the game and complexity of the scene. Implementing these spatial sorting algorithm can significantly improve game's performance and realism by ensuring that only relevant objects are processed in real time. Now let's discuss some of the spatial sorting algorithm. The very first one is bounding volume hierarchy. So BVH is a hierarchical spatial sorting algorithm which is widely used in real-time 3D graphics and ray tracing. It organizes objects in the scene into a tree structure like you can see in the right side that build a diagram. So here the root node is considered as a bounding box. It encloses all the objects in the game scene, and the root node is split into three nodes. These three nodes, node 1, node 2, node 3, are called as sub or internal nodes of bounding box. The node 1 encloses another subnode called node 4, and the object 1, object 2, object 3, object 4, no, objects 5. All these objects are the elements of game scene. So this hierarchical structure helps to decide the order in which they should be processed. During rendering or collision detection, the BVH tree is traversed from root top. The traversal prioritizes the routes that are nodes that are closer to the camera or relevant for collision detection. BVH reduces the number of objects that need to be processed in each frame, as distance object can be quickly discarded. So the next comes grids. Grids are straightforward spatial sorting technique. So this divides the entire game world into regular grid of cells. Each object in the scene is assigned to one or more grid cells based on its position and size. Each cell in the grid can contain objects that are located within its boundaries. So during rendering or collision detection, only objects within or intersecting the same grid cells are considered for processing. This ultimately reduces the number of object checks. So the object checks. Grids are especially effective in 2D games. And the next comes octrees. Octrees is one of the spatial sorting structure that divides the 3D space into octants, similar to a 3D grid. So the entire scene is contained into a root octant, and each octant can be further subdivided into 8 octants. In the below diagram you can see that the first there is a root node, and that is subdivided into 8 nodes, and one of the 8 nodes is subdivided into 8. Like this, the octant will be subdivided into 8 octants. So the octrees are particularly useful for efficiently managing large 3D scenes. They allow for quick culling of the entire sections of the scene that are not visible or relevant for collision detection. During traversal, the octrees prioritize only the closer octants, similar to BVH. So an octree divides the 3D spaces into octant processing. The top level cube contains the entire 3D scene. It divides into smaller cubes, each representing a portion of space. And each of these octants can be further subdivided if they contain objects. This subdivision continues hierarchically until each cube contains a manageable number of objects or it reaches a specified depth. Objects are assigned to the smallest cube that fully contains them. So this is all about the spatial sorting algorithm. Thank you for watching. Please do like, share and subscribe.